Hello friends, in this video we are going to study from chapter 5 of Surveying 2. The chapter is related with curve ranging. So we have studied a lot about curve ranging in previous few lectures. In this lecture we are going to study elements of the simple circular curve. So you know what is simple circular curve. So when two straights of a route are connected by a single circular arc, it is called as the simple circular curve. So this is the rear straight, this is rear straight, this is the forward straight, okay, and this is that simple circular arc used to connect these two straights, okay. So this is that simple circular arc, okay. So this curve will be called as a simple circular curve. So usually this first straight or rear straight is named by a letter A and B, whereas this forward or second straight is named by the letters BC. So here AB is the rear straight and BC is the forward straight, okay. And the point of tangency, so this will be the point of tangency of the circular arc with the straight. It is called as tangent point 1 or first tangent point and denoted by T1. So this will be denoted by T2. This is forward or second tangent point, okay. Now I am drawing radius to the curve. So these are radius to the curve and this is the center of curvature, okay. So this is the long chord and this is the bisector of the central angle, this is midpoint of long chord and this is vertex or summit of the curve, okay. So now I'll study the principal points, principal lines and principal angles, okay, to the curve, and then after we'll enlist elements of the curve. So first we'll list the principal points. So what are the principal point? So first principal points. First principal point is the O, that is center of the curve. Second principal point is the point of intersection B. This one, this is the point of intersection. Then third principal point is the T1, which is known as first or rear tangent point, or it is also called as tangent curve, because at this point the straight line, the tangent is getting converted into the curve. The fourth principal point is the T2. It is called as second or forward tangent point, or it is called as curve tangent. Why curve tangent? Because at this point the curve is getting converted into the tangent. The next principal point, the fifth principal point, is this point E. It is known as midpoint of long chord because it divides long chord into two equal parts. And the last principal point is this F. It is known as apex. Sixth principal point is known as apex or summit of the curve. Okay. So these are 6 principal important points for the curve. Now I'll study the principal lines. So before going to the study of the elements of the curve, one must know the principal points, lines and angles important in respect of the simple circular curve. So we have already enlisted 6 principal points. Now we are enlisting the principal line. So the first principal line, this line OT1 or OF or OT2 is equal to R and known as radius to the curve. OT1, OT2, then OF, radii of the curve, and it is abbreviated or denoted by R, letter R. Then second principal line is the T1B. T1B is called as first or rear tangent. The next principle, this T1B is the first or rear tangent. Now second is the BT2. Third principal line is BT2. It is called as second or forward tangent. The next principal line to a simple circular curve is a T1ET2. This line T1ET2 is called as long chord. You know what is chord? A straight line joining 2 points on a curve is called as chord. Then fifth principal line is this EF. It is called as versed sine. This distance EF is called as versed sine. Then sixth is FB, distance FB. This distance from here to here. It is called as apex distance or external distance. And the last principal lines, last two important principal line with which we started drawing of this curve is line AB. This line AB is called as first or rear straight to the curve. And this line BC is called as second or forward straight to the curve. So these are 8 principal lines to any in respect of any simple circular curve. Now we have to discuss the next point, that is principal angle. So the very first principal angle is this angle T1OT2. T1OT2. This angle T1OT2 is called as central angle. The second principal angle is this angle T1BT2. T1BT2. This angle T1BT2 is called as angle of intersection. angle of intersection. And the last angle is this angle B dash BC, this angle. This angle is the angle of intersection. It is denoted by I. And this is the angle delta. Angle B dash B T2. This is called as a deflection angle. And it is denoted by delta. So now it is very clear, this is delta plus I, that is deflection angle plus angle of intersection, is equals to 180 degree. Barabar? Then we also know the central angle for time being, this central angle we'll call it as say C, or say theta. We'll call it as theta. This, you know that this quadrilateral T1B T2O is the cyclic quadrilateral, and we know that in case of cyclic quadrilateral, sum of opposite angle is always 180 degree. So that's why the central angle theta and angle of intersection I is equals to 180 degree. So here I may say delta plus I is equal to, therefore delta plus I is equals to theta plus I. So here I gets cancelled, and we may state delta is equal to theta. What is delta? Delta is deflection angle. And what is theta? Theta is central angle. So we can say that the central angle T1 O T2 is always equals to deflection angle B dash BC. Now finally we'll conclude by enlisting elements of the circular curve. The very first element of circular curve is tangent length or length of tangent. So length of this tangent BT1 or BT2 is called as a length of tangent. It is denoted by small l, and we can prove that this is R tan into phi by 2. So length of tangent. So tangent length or length of tangent. Then second important, now we are discussing or we are enlisting the elements of the circular curve, and we have enlisted the first element, that is tangent length. Now second is the curve length. Curve length is usually denoted by letter capital L, and we can prove that capital L curve length is equal to pi into R into phi, phi deflection angle in degrees, divided by 180 degree. And third important element of the simple circular curve essentially required in the process of setting out, ranging out of the circular curve is the length of long chord. And that it can be shown as it is equal to 2 into R into sine of phi by 2, where phi is the deflection angle. Okay. The next element of the circular curve is the worst sine. So this distance EF is called as worst sine, and it is equal to R in bracket 1 minus cos of phi by 2. And the last element of the circular curve is this external distance. External distance. Worst sine is EF. External distance is BF, and that is equal to R in bracket sec of phi by 2 minus 1. So length of long chord is this T1 ET2. So now we have enlisted the 5 elements of a circular curve, and also we have written the formulas for this. So we'll summarize the elements. The first element is the tangent length, it is denoted by small l, and the formula to work out tangent length is small l is equal to r into tan phi by 2, where r is the tangent length. Okay, so the second one is the curve length. It is denoted by capital L, and curve length capital L is equal to pi into r into 5 degrees divided by 180, where r is the radius to the curve and phi is the deflection angle. Then the next element is length of long chord. It is T1 E T2, and that is equal to 2r sin phi by 2. The fourth element is the worst sine. This distance EF is known as worst sine. Many times it is also known as mid-ordinate, and it is worked out by the formula r in bracket 1 minus cos of phi by 2. And the last element is external distance. This distance BF is known as external distance, and it can be worked out by using the formula r in bracket sec of phi by 2 minus 1. So this is what I have to discuss in today's lecture. So we have discussed principal points, principal angles, and principal lines in respect of a simple circular curve. And then we have enlisted elements of the circular curve, and we have written the formulas to work out the elements of this circular curve. So we'll stop for today. Thank you very much for patient listening. Okay, see you next time.